A short UI demo and then dive from there into coding against our APIs. CDO is a very old technology these days, 12 years old at Eclipse. Over the years, we've added lots and lots of functionality. Of course, we can't show everything here, so we'll mostly focus on thread safety, transactions, garbage collection, change notifications a little bit. For those that have never used CDO before, imagine you have an EMF application, you deploy it to multiple computers in the network and they connect to a central model repository. Then the users can change objects of the object graphs in these applications, commit the changes into the repository. The repository emits invalidation messages to the other clients so that when they access the same objects again, the new state is reloaded from the model repository. What happens in the model repository? When the client application commits changes to these green objects here, we create so-called revisions in the model repository. Revision is a little bit ambiguous, the term. In SVN, it means something different. It means a whole baseline or a commit. In CDO, a revision is the state of a single object for a certain period of time. So here we see 3 revisions, both the version 1 of these 3 objects. When other objects are changed, you see old revisions are overwritten in the underlying database. That is the normal mode of operation of CDO. We have an additional repository mode and we call it auditing, because when the same thing happens in the application, we never overwrite existing revisions. We keep the old ones, create new ones, and then we can later do something that we call auditing and roll back, do time travel through the models, and I will hopefully find time to show that. There's a third mode which includes auditing, but you can also create branches and then you have, again, a different dimension of these revisions for the same objects. These revisions are very essential for CDO. You can think of them as data transfer objects. They represent all the data in an E-object, some meta information here, in what branch is it, what is the version, what is the period of time when it is valid, and so on. The modeled values, they are all stored in an array. And we don't store references between revisions. You see that a revision has a technical ID. So for references, we store these IDs of the target objects here. And that means we can easily transfer them over the network or store them in a database and so on without these references. So what happens in a typical CDO client application? The first thing you create is a session. You open a session to the repository. The session operates or communicates over the network through a so-called Net4j protocol. And the session contains some infrastructure, for example, a lazy package registry. These packages are also stored in the repository and they are lazily loaded when they are needed. One of the most important components of the session is the revision manager. It consists of a cache, a local cache of revisions, and a revision loader. And the revision loader here is the protocol. So here we have an example of 4 objects. You see here the so-called CDO IDs of the objects. And we have the different versions that were created over time. With these revisions, they are not E-objects, so it's a little bit a technical concept. Your application typically doesn't want to interact with them directly. What you want is an E-object, and I'll show you how that works with just one logical object here. What you always need to access the model graph, the E-object graph, is what we call a view. So this is an E-object, and it always points to a CDO revision. And such a view always points to the latest revision in a specific branch. This view, it looks at a branch at a specific time. There's another special view, an audit view. There you can say, I want historical versions of the graph. And it's the purpose of this audit view to find all the revisions for all the objects at this point in time. The first two views here are read-only. So if you try to call a setter on these objects, you will get a read-only exception. We will see later why that is still helpful and can be a good thing. But at some point you want to create new objects or you want to modify the attributes, then you need to open a transaction. That is also a view, it's a sub-interface of CDO view. And a transaction also always looks at the latest revisions of a branch, but you can change these objects. When you call a setter on this object here, this latest revision is copied into the transaction. It becomes a transactional revision. Then you can change it, and when you commit the transaction, all these changes are sent over the wire to the repository, stored in a database. The other clients are notified. A response comes back. And if you paid attention, even this view here, this read-only view, automatically rewired the objects to the latest available revision. Okay. So we have seen the revisions. We know that the CDO objects are a little bit different. How do the objects look like? You may know this example from the library example from EMF. So there's this class bookImpl. And if you look at these two structural features, they are references. In fact, I think the category is an enum. So let's just talk about the writer, the author reference. When you generate this model, the author reference is a field in the class, and it is a strong Java reference. And that means the garbage collector cannot remove the author from memory when the book still points to it, and it will always point to it. In the end, it's typically the case that all your models are so tightly referenced that all of them stay in memory as long as the resource set stays in memory. So nothing can be garbage collected, and that limits the size of the models that you can use. And we didn't want that in CDO, so what did we do? We just cut out all the generated fields from the classes. So it has no strong references anymore. Each CDO object can be garbage collected individually. And we do that with a generator property, EMF generator property, reflective or dynamic delegation, feature delegation. We use another one. I mean, now these fields are all gone, but where is the model state stored? That's the next question. And we use another generator property to solve this problem. We inject our own base class in between eObjectImpl and your model class, and that is the CDO object impl. So that means when you want to work with scalable models, with models of arbitrary size, you have to regenerate your models with these few settings, and we have a migrator tool. I will show that in a minute. You don't have to do that. I mean, you don't need to do that. If you don't care about model size, you can just use a normally generated EMF model. From a CDO perspective, we call that legacy models, in contrast to these native, CDO native models. So these native CDO objects, they have just 4 fields in Java. That is the technical ID, that is this revision pointer that we saw on the previous slides that can easily be switched between the different revisions. It has a pointer to the view that maintains this object, and a state. This state is important because all objects, when you create them, so you pull them out of an EMF factory, they are in state transient. The repository doesn't know about them. You need a transaction, a CDO transaction, and then you can attach this object to the tree, to the already persistent tree, and it becomes a new object. When you commit that transaction, the object gets to clean state. When you call a setter on this object, it becomes dirty, and when you commit again, it's clean again. Then you remember that the model repository notifies other EMF clients, other CDO clients. When that happens, loaded objects go into a proxy state. That basically means the revision pointer is set to null. And when your application calls a getter on this object, it is read from the repository and it gets into the clean state again. What happens if this remote invalidate event happens in this dirty state? Then the object goes into conflict state because you had already changed it locally, then someone else was quicker to commit it. So in your client, you get aware of that quickly. Yeah? In normal databases or so, you only see conflicts when you commit. In CDO, you have fail early transactions because you already get this event and you know I will not be able to commit it in the future unless you set conflict resolvers into your transaction. Sorry, that was too quick. Normally, you would roll back your transaction and then the object goes back to proxy and typically go through this path into clean state again. But then all your changes are lost. They are rolled back. We have so-called conflict resolvers. You hook them into your transaction and they try to resolve these conflicts while they happen. And it essentially merges your local changes with the remote changes and brings the object state back into dirty, and you can then commit it later. This state machine in CDO, it interacts with the objects through this internal interface. And there are two hierarchies of classes. These are the CDO native objects. That's typically all classes, all of your classes that are generated specifically for CDO, including dynamic CDO objects, those where you create the classes at runtime. For all models that you cannot regenerate, let's say GMF diagram, the notation model or stuff like that, models that you get from somewhere else, you can also use them and they interact with the state machine through our so-called legacy adapters. That's an internal detail, you just don't realize it. But the instances of these classes are not scalable then because they have strong Java references. Last slide, I think. CDO comes with a system built-in model for a file system structure in the repository. So you see concepts such as folders, resources, binary, and text files. And the important thing here is these are EMF resources and E-objects. The background was that CDO can perfectly store E-objects. So when we wanted to store resources and files, we said we make them E-objects and then we can store them out of the box. Keep that a little bit in mind, that CDO resources are both resources and E-objects, because some frameworks do instance of checks to see whether a notifier is an E-object or a resource. And there it depends on the order they do these instance of checks. That's just a side note. Okay, now it's demo time. I prepared a very, very simple model for you. It's about banks. A bank has accounts, just an owner, a name, and a balance. And these accounts can have transfers. And a transfer is nothing than an amount of money that goes into the account or out of the account. So, here you see this model. I made that with eCore tools, the Sirius-based new version of eCore tools. Check the time. So I already generated the Java code, and here you can see that this is still a legacy model. I'll show you how easily you can switch it to a CDO native model. We have a migrator tool. So you can choose here between reflective and dynamic feature delegation. That's a difficult topic. The short explanation is reflective feature delegation is fast and dynamic feature delegation is more powerful. So especially if your generated model has handwritten changes in the getters and setters, those changes would be ignored with reflective feature delegation. So just in that case, when you have that, use dynamic feature delegation, and then those handwritten getter changes will be known and used by CDO. We don't have that here, so I can say reflective delegation. Here just a quick overview what it has changed in the gen model. Then I need to regenerate the model. And now, in fact, we see now it's a CDO object impl. All the fields have gone. The getters look more like this, and this explains why it's called reflective feature delegation. And in this case, the interfaces also extend CDO object, but that's optional. You can keep it on a pure EMF layer here in the interfaces. Good. Then, let me see. So now I start a new workbench where this generated model is deployed so that we can use it. And of course, in this workbench that I now launch, we have our native banking model, and we have a complete CDO client and even a CDO server. So the first thing we do here is I create a new repository, and I can do that with our comparingly new CDO Explorer user interface. So there's the CDO repositories view. I don't connect to an existing remote repository, I just create a new local one on the fly. The only things I change here is the CDO IDs. I want the faster counter IDs. And I enable a TCP port in addition, because later I will start other clients that connect to it. So there we go. Repository is created. From here, I will create a checkout. That can be a little bit confusing, so we call it an online transactional checkout. We don't have any files in the workspace here. This is really just a visual integration with a project explorer. If you don't trust me, you can have a look how that looks in the file system. It's really just a properties file that has some meta information. What did I check out? So from here we can build up this file system structure that I showed on the slides. We ignore all the other things and create directly a model resource. Let's call it banking. I open our CDO editor on it, and I want to add a bank. So I pick our banking model. There's some display problem here, I'm not sure what that is. I want the bank. Oh, I think I'm screwed here, I'm not sure what that is. Let me undo that. There must be an exception somewhere. Jesus. Modeling perspective. I've run through it a dozen times. Maybe I undo these native generation steps. I'm really not sure what happened here. So maybe I just restart it. In fact, I think I tried it with the legacy models, but of course it should work even better with the other ones. Check out. Oh, there's something wrong with the model, I think. I don't know. What is that? So give me a sec, please. I'm sorry. So we try the legacy variant of these models. Please. Looks better. I'm not sure what it is, but okay, now I have to rush. So you can build up the model and change objects in the Project Explorer or in an editor. That just doesn't matter. So I create an account here. The owner is myself, and maybe a second one for Mr. Merckx. And you see at the time I committed, they appear here too. So this here is shown by a CDO view, and this behind the editor there's a CDO transaction, so they are updated by these change notifications. Okay, so what's the time? So I quickly want to show you client code now. I've prepared an Eclipse view that should list all the accounts and that I can use to create new accounts and transfer money between the accounts. Of course, there's a little bit of boilerplate code for Eclipse, setting up the viewer, attach this drag and drop stuff and so. So that is all in this abstract base class. I don't go into details here, okay? The point is when a new account, when the user says I want a new account, then this method is called, and for transfer money this method is called. And they are implemented here. So if we look at them, or maybe I first demo what happens. Of course, I must start another workbench from the started workbench to deploy this plugin. Meanwhile, we look a little bit at the code. I don't open a new CDO session here because you will see that in this new runtime here, I've configured a remote repository and connect to the other repository. So I just have to open it, create a checkout, and I see exactly what's in this model repository here, yeah? So and now when I select this bank, I use exactly this bank object to query the accounts here. And that requires no own code. It's a normal EMF content, adapter factory content provider, and an adapter factory label provider. So from here I can easily do this drag and drop now, I thought at least. Why not? Maybe because, of course, there's no money on the accounts. Jesus, yeah, I built in a check to check that there's at least €1 or $1, I think, in that account. So here you can see I can transfer the money just by clicking, and you see that all the other views update totally automatically. You don't need to write a single line of code to make that happen. Yeah? And of course, also in the other IDE, which is really a different session, could be on another computer. Display is so small here. Maybe I do it here. So when I transfer the money here, you see that on all machines in the network, it updates immediately. So how does that look like? So I get the bank object, the one I selected in the IDE, I get it passed in here. This is the real business logic that is coded against your model interfaces. And this here is an interesting pattern in CDO. From the view of this input object, I get to the CDO's underlying session. From there, I can open a new transaction. And then I use this transaction to get a transactional version of the bank. This is a very common pattern. You see the same thing in the Project Explorer. I told you that this is a read-only view. So you could ask, how can I create new resources here? That doesn't happen in this view. I spawn a new transaction from there. There I do the modification, the creation of the new resource, commit it, and the notifications update the original view. And so if you want to build user interfaces with CDO, that's a very common pattern, and keep that in mind, please. And these views, because they are read-only, you can use them in many places in your application. There's no conflict potential because the objects of these views cannot be changed. Okay, so what do I do then? So I have this transactional bank, then I create the new account, set the balance. Here the bank donates $100 already, an initial transfer to the account. The account is added to the bank, then the transaction is committed. And because I want to select the new account, I must wait for the read-only view to receive this notification, and that is done with this small trick here. The return value of the commit is a commit info object that has the timestamp of the commit, and in CDO the timestamp of a commit is the commit ID basically. The server makes sure there's only one commit per millisecond. Then the view waits for that time, and then this here is the reverse operation of this here. So I transfer the object back from the transaction into the read-only view, and then I can return it. I'm going to zip all these examples up. So this was a little bit quick in half an hour. You can download it if you're interested. This is a very common pattern. And one last thing I would like to show, if you don't mind, is how to open a session. And I prepared a standalone program here. So we just pull the session out of this wiring container here. And within Eclipse, this container just works. All the needed factories for creating the network connection, the CDO session, buffer pool, and what else is needed, that it works through the extension registry. In standalone, you must prepare this container, and that's what I do in the static block here. So in Eclipse, you wouldn't need that. With this session, you could, for example, create branches. So have a look here. when I run this program, run this, a new branch has been created. And it's immediately visible in all clients, of course. To access the model, you need to open a view again. And here I have a nice example. This is a balance checker. It runs through all accounts of the bank, and then it sums up all the transfer amounts and compares the result with the balance. And that should always be equal, of course. So let me run this. So in case it's not equal, it would print out wrong balance. So I can simulate that by going to an account, let's say this TTT account here, and add $1. And then it would immediately find that out and print it out. And when I change it back, I hope I did it in the right, was 97, huh? I knew that would happen. So then it stops. What I wanted to show here is really a different thing. This is not very intelligent code, but if I remove this sleep here so that it does the iteration over the lists more often, what would happen then? I restart it and I change it again. And I do it again. Maybe I use my other client here. There I can do transfers more quickly. There it was. This is what I wanted to show you. I get a concurrent modification exception. That is because this invalidation event came in while I was iterating over the list. And in general, CDO models are thread safe, but only the single operations. Yeah? If you do multiple operations and don't want to be interrupted by this background thread, you need to do the following. It's pretty simple. You wrap your operation into this call. You tell the view, execute this runnable without being interrupted by any other threads. And if I run this guy here, I guess you believe me that it's thread safe. This exception wouldn't occur. Okay, time is running quickly, so maybe you have some questions. Sorry, I destroyed the equipment.
Do you have something like CDO compare between
yes.
version sets?
The question is, do we have compare, visual compare? And we do have that. So let me try to demo that. So let me create a new branch from this state that we have here. Okay, that's pretty simple. New branch, XXX. By the way, of course we have very nice history support. From this branch here, I create a new checkout. So you see now I have two banks and two branches. And let's say, I want to have money too, like so. And now I can just compare these two. Difference between inputs. I thought at least. There you go. And you can, of course, also quickly merge it. So I accept that change, save the editor, and that has transferred the $100 into the other branch.
What about performance? I mean, for example, can I use CDO as an alternative for GPA? For example.
Performance was the question. How does it compare to Hibernate? So we have a Hibernate integration. Most people use CDO with relational databases, but you can use Hibernate, you can use MongoDB store and some others. They are not so well tested. The Hibernate integration is not maintained anymore, I think. Martin Thal has left that project. And my information from customers and users was that our proprietary OR mapper is much faster than Hibernate. And it definitely supports more use cases, branching, merging, and these things. By the way, you see, this is a brand new thing since last week. We now store information about merges too, visualize it, and even make use of it for the next merges. Please.
What do I have to do with my meta model changes?
Okay, that is my hate question. The question is about model evolution. When typically your business changes, next your model changes, your meta models, what happens with existing instances of the old meta model version? And we still have no automated support for that. There are some acceptable workarounds. We have repo exporters and importers into an own very scalable XML format. And you can easily import that into an XML database, have some migration scripts. It's not so nice, it works. I'm looking, if you have budget to fund this last piece, it's really one of the last big pieces, missing pieces in CDO, to have a nice and automatic support for model evolution.
So, speaking about that, I have...
How do people go about doing this?
Sorry, say it again.
So how is it done in practice? Evolution of the model?
Yeah, mostly, as I said, it's an export script. Yeah, so this this repo exporter, it exports the entire history of the repo and everything. You can recreate it in an identical form on another machine, for example. Then you have an XML file. The format is very, very simple. It's a generic format. And then you can use XML tools to migrate that XML file, and you would re-import it into a new repository. That is, in my opinion, the best way. I know of people who use technologies like, what were the names? There are some, pardon? Yeah, EDAPT. I think EDAPT is more for authoring the changes and managing the model changes. No, what I'm after, there are database tools which are able to Liquibase is one of them, and there's another one which I don't remember. Flyaway or something like that, yeah. So there are a number of approaches. I think none of them is ideal from a convenience point of view, at least. But for that, we need funding.
Our team has been struggling with schema evolution for a while, and the best thing we have found is Apple core data.
What is that? App?
If you program apps,
Mm-hmm.
you can use core data
Mm-hmm.
framework, the consistent framework, and then if you modify the model, the applicable model, then the app will migrate the data automatically for you when the app is started.
I haven't heard of that, but maybe I write it down later and go investigate.
There are two things that I have the CDO for the last 6 years, and there are two things that would be and that's suggestions, which is the first one is especially when I come from G experience, so when I started working with transactions and views, for me it was again to write the transaction not using annotations to then provide an indentation based on method start and method ends. That would be nice because it provides less code.
To provide what?
Less code. I mean, it's like in G when you, instead of writing explicitly that you are creating or deleting a transaction, you use the indentation.
With annotations, you mean?
Exactly.
Ah, okay, yeah, I thought about that a few years back, but we're so far busy with other things. Yeah, it's probably possible and maybe a nice thing. I doubt that I will work on that soon,
Yeah.
but contributions are always welcome, and we can discuss it up front. And
Another one is maybe that's even more complicated, which is having some kind of a part of that for Java accessing, have some kind of REST accessing, for example, for building operations like getting sources, something very
REST access to the model repository. We don't offer that out of the box in CDO. I know that the UBS bank in Zurich, they have created such a thing. They told me it was not very difficult, it's not much code. Unfortunately, I lost track of that at some point, but we could do it. Contribution would be welcome again. Yeah, we have lots of cool query stuff in CDO. We run out of time. So the view and the transaction, of course, has a method, create query. It's a generic query framework, so you pass the query language and a query string, a map of parameters. That is transported to the server. There we use typically the query language string to find a query handler that executes the query, and the results are transported back synchronously or asynchronously. You can use SQL as a query language, OCL. You can write your own ones. It's very easy. Yeah.
Is there a way to block these updates?
To block what?
Tree clients, for instance, from the same repository, and all of them is doing an update. So we have this
Yeah.
invalidation, notification, and stuff. Is there a way to block this updates on the knowledge graph?
Yeah.
See the changes immediately?
So I think the simplest way is that you use explicit logs. And in fact, I had such an example. I think I can show it here. I think I'm getting confused. I don't know which IDE it was anymore. But you can place explicit logs on single objects. Well, I can show it in the UI. So if I open this bank here, I could say, please lock this part of the tree, and then the other one cannot change it anymore. And as a consequence, you don't get updates to this part of the tree.
The other one should be able to work.
Mm-hmm.
But on my instance, I don't want to see the updates.
Yeah, that is possible. The easiest way.
We are building models, and then these are process models, and on other machines we are running these processes, and we don't want them to change just like that while they're still running.
Yeah, the easiest way is that you go to here and say, there's a dot missing. Oh, Jesus, it doesn't work here. Set passive updates enabled to false. Then you get no updates from the server. There are more fine-grained methods too. You can configure so-called change subscription policies, where you can specify exactly for what objects you want these updates and so on. Okay, then thank you again. Have a safe trip home. Bye-bye.